There are many functions without elementary antiderivatives, such as the sine of x divided by x, or x to the power of x. Of course, it's possible to integrate any continuous function as long as it doesn't diverge. However, there is no elementary function that we can use to do this. So to compensate for that, mathematicians actually had to define the integral of sine of t over t dt from 0 to x as si of x, also known as the sine integral. And that's pretty much the most you can do without constructing the Taylor series and integrating term by term. So let's take this function, the integral from 0 to 1 of x squared minus 1 all over the natural log of x dx. Now if you graph this function, it looks a little like this. And clearly there is some finite area under that curve, but if you try to find the antiderivative, you will unfortunately fail. Our friends at Wolfram Alpha say that the indefinite integral is the exponential integral of 3 times the natural log of x minus the logarithmic integral of x plus c, where the exponential integral and logarithmic integral are both special integral functions, just like the sine integral, that you can't take antiderivatives of. It's ugly. But it is possible to evaluate the definite integral. It's called differentiation under the integral sign. First, let's define a more general function, I of b. I will stand for integral. So we'll say that I of b is the integral from 0 to 1 of x to the power of b minus 1 all over the natural log of x dx. Now this might seem a bit weird as it looks like we're making the integral even more complicated. We now have a function in terms of b. If b is 0, then quick arithmetic shows that the integral is 0. What we want to do is simplify this integral until we find I of 2, which would be equivalent to the original expression we were trying to find. Let's take the derivative of I of b, and we get I prime of b equals the derivative with respect to b of the integral from 0 to 1 of x to the b minus 1 over the natural log of x dx. Now, according to the Leibniz rule, the derivative of an integral of a function of two variables is equal to the integral of the partial derivative of that function. So what does that mean? That means that if we take the partial derivative with respect to b, we can find I prime. A partial derivative means that we pretend that x is a constant and take the derivative of b. A partial derivative is indicated by these curly deltas. So for example, the second term, 1 divided by the natural log of x, is actually a constant. So when we take the derivative, it just disappears. Very convenient. So when we hold x constant and take the derivative with respect to b, x to the b becomes the natural log of x times x to the b all over the natural log of x, which we can quickly prove if we take y equals x to the power of b, take the natural log of both sides, giving the natural log of y equals b times the natural log of x, and then differentiating that we get 1 over y dy db equals the natural log of x. dy db equals the natural log of x times y, and dy db equals the natural log of x times x to the power of b. So going back to the problem, we found that I prime of b equals the integral from 0 to 1 of the natural log of x times x to the power of b over the natural log of x dx. Or simply the integral of x to the power of b dx when we cancel out the natural log of x. Now what's slightly confusing is that x is now no longer a constant. Instead, we hold b constant and integrate because we're integrating with respect to x. So if b is some constant, this is literally just the power rule, and we get x to the power of b plus 1 over b plus 1 from x equals 0 to x equals 1. Now all we have to do is plug in our limits and we get 1 over b plus 1 because the numerator here is just 1, and then subtract 0 because everything here drops out. So now we have I prime of b equals 1 over b plus 1. Doesn't answer our question though. At this point, it's relatively simple. You're given a derivative and you need to find the function, so what do? You integrate with respect to b, and you get the integral of 1 over b plus 1 db, which is the natural log of b plus 1 plus c. So how do we find c? Well, let's take a value of b from the original integral that we know the answer to. If b is 0, then we know that the integral is 0 because 1 minus 1 in the numerator is 0. So we can say that the natural log of 0 plus 1 plus c equals 0, and some quick math will tell you that c equals 0. So I of b equals the natural log of b plus 1. Are we done? Almost. All we have to do is answer the question, which is the particular integral when the exponent b is 2, which is the natural log of 2 plus 1 or the natural log of 3. And we're done. Well, let's look at another one. Off to you, other disembodied voice.
Okay, let's look at another one. So, this is what we call an ugly integral. Integral from 0 to infinity of e to the negative x minus e to the negative 7x over x dx. It has no elementary antiderivatives. Now, normally you'd have to do some guessing to find which number to substitute, and it might not even work, but with some luck you might try substituting b into 7, like so. What do we do next? Well, we find I prime of b by differentiating under the integral sign. So, I prime of b equals d db integral 0 to infinity e to the negative x minus e to the negative bx over x dx. Now, we find the partial derivative with respect to b of what's under the integral by treating x as if it were constant. Just like before, a large chunk of the thing just drops out. Because we're pretending x is constant, e to the negative x over x is also constant. So, when we take the derivative, we get 0, since the derivative of a constant is 0. Taking the derivative with respect to b of negative e to the negative bx over x gives us positive x e to the negative bx over x by using the chain rule. And these two x's cancel out. So, now we have I prime of b equals integral 0 to infinity e to the negative bx dx. And now, confusingly enough, b is a constant again and x is the variable. We know that the antiderivative of this is e to the negative bx over negative b from x equals 0 to x equals infinity. Plug in those values and we find that e to the negative infinity b over minus b goes to 0. E to the negative 0b is 1, so finally we have I prime of b is equal to 1 over b. Much simpler than it was before. Quickly integrate and we find that I of b equals the natural log of b plus c. So, how can we find c? Well, what value of the original integral can we find out? We can see that if b equals 1, then the numerator is always 0, making the integral 0 as well. Using this, we know that the natural log of 1 plus c equals 0, or c equals 0. Last step, we know that instead of b in the original equation, we had 7. So, to find the value of the integral, we simply find the natural log of 7. And we're done.